Welcome to A-Level and AP Physics. In today's lesson, we will discuss a typical type of question on measurements from March 2022, paper 2. In this question, we will discuss especially about SI based units. We will discuss how to deal with SI based units. We will also do some other calculations about measurements. In this lesson, we are talking about paper 2 from March 2022, and exam duration for this paper is 1 hour and 15 minutes, and total mark for this paper is 6. On second page of exam paper, you can find some important constants and their values. The first constant is acceleration of free fall, and its value is equal to 9.81 meters per second per second. You have to use 9.81 at AS level. You cannot use that. So you have to be very clear about this one. Next one is speed of light in free space. And this is also about equal to speed of light in air. It is also equal to speed of light in vacuum. Free space and vacuum are the same. So this is value of C. Next one is elementary charge. I mean, this is the smallest possible charge on any particle which can exist independently. So smallest charge is the charge on single electron, because electron is fundamental particle. Next one is atomic mass unit, and this is equal to 1.66 times 10 to negative 27 kg. Next one is rest mass of proton. Rest mass of proton simply means that when the proton is not moving or the speed of proton is very slow, so we can use this mass. At AS level, you don't need to worry about relativistic effects, so simply when you need to use mass of proton, you can use this value. Next one is rest mass of electron, and this is equal to 9.11 times 10 to negative 31 kgs. Same, rest mass means when electron is at rest, the speed of electron is quite slow as compared with speed of light. So then mass of electron is equal to this. Avogadro's constant. So here is value of Avogadro's constant. Next one is molar gas constant. You need to understand, maybe you need for some calculations, Boltzmann constant. So value of Boltzmann constant is given. Gravitational constant. You will need this one for A2. Maybe you will not need this one for AS physics. Permittivity of free space. Maybe you will not need for AS level, but you will need this for A2 physics. Next one is Planck's constant. This is also required for A2 physics. Last one is Stefan-Boltzmann constant. This is also part of A2 physics. On third page of exam paper, you can also find some important formulae. Let's try to understand some important points about use of these formulae. The first thing you need to understand here, this S. This is not the distance. This S is representing, in fact, displacement. So you have to be very clear. This is displacement. This is not the distance. Distance and displacement are equal when the body is moving in a straight line. If the body is not moving in a straight line, then distance and displacement, they are not equal. Displacement is equal to distance only if the body is moving in a straight line and direction of body is not changing. Body just move in one straight line in one direction. Then distance and displacement, they are equal. Otherwise, they are not equal. The second thing you need to understand is about A. In this formula, A is uniform, means A is constant. So you can use this formula only if A is constant. So A is uniform acceleration, means A has only one value. A is not changing with time. So if you want to use these two formulae, you can only use them if acceleration is uniform. Otherwise, you cannot use them. U here is representing initial velocity. So we can say U is initial velocity. V here is representing final velocity. So V is final velocity. If you go to next formula, this is about hydrostatic pressure, delta T, and this is delta H. So this is the change in depth. So you have to be very clear. What is delta H? This is change in depth. And rho here, this is density of fluid. Or simply you can say density of liquid. So this is density of fluid. Next one is upthrust, very important one. V here, this is volume of fluid displaced, not volume of object. So this is volume of fluid displaced. Very important point. You have to be very clear about this one. Volume of fluid displaced. Now we need to understand when volume of fluid and volume of object, they are the same. So we will discuss two separate cases. First case, when object is fully submerged. So I will be writing here when object is fully submerged. Fully submerged simply means that, let's say we have this container and we place one object inside. Let's say object is here, is fully submerged. In this case, volume of fluid displaced is equal to volume of object. But when object is floating, you can understand simply from here. Let's say we have this liquid and object is floating. In this case, mean object is somewhere here. In this case, volume of fluid displaced and volume of object, they are not same. So you have to be very clear about this. V is the volume of fluid displaced. When you can use this one equal to volume of object if the object is fully submerged, that if the object is floating, object is not fully submerged, you cannot use volume of object here. And rho is density of fluid. So this is density of fluid. Rho is density of fluid. Next one is about Doppler effect for sound waves. Fs is the frequency of the source, v is the speed of waves, and vs is speed of source. If object is approaching, so we will discuss the first case, object is approaching. If the object is approaching, you can simply modify this formula. We can say in this case Fs v over v minus vs. But if the object is moving away, so we can write down here object is moving away. If object is moving away, then observed frequency is equal to Fs. V means speed of the wave divided by v plus vs. You need to understand when to use negative sign, when to use positive sign. Next one is electric current. So n here, this is number density. I mean, this is the number of free electrons per unit volume. N here is number density, and v here is the drift speed. Simply we can say, actually this is drift velocity, better to say. So this is drift velocity. Number density means number of free electrons per unit volume. And next formula is about resistors in series. So this is you can use when resistors are connected in series. The last one is about resistors in parallel, when the resistors are connected in parallel. This is how you can calculate. For question number 1, it is given to us a sphere of radius 2.1 mm falls with terminal means constant velocity through a liquid as shown in figure 1.1. So you can see this sphere, this is falling at constant velocity and its direction is downwards. It is also given to us three forces act on the moving sphere. The weight of the sphere is given to us. Upthrust on the sphere is also given. It is also given to us viscous force Fv act on the sphere, and we can calculate Fv means the viscous force using this formula. In this formula, r is the radius of the sphere and v is the velocity. K is a constant and the value of K in SI units is 17. We need to determine SI base units of K. First of all, let's try to understand what are SI base units and why we call them SI base units. First thing we need to understand, these are SI base units because in System International, if you need to derive unit of any physical quantity, you can express unit of that physical quantity in terms of SI base units. So means these units are the base of any other unit in SI system. Let's try to understand a little bit more about SI base quantities and SI base units. First quantity is length and its unit is meter. Next one is mass and its unit is kg. Next one is time and its unit is second. Then we have temperature and its SI base unit is Kelvin, not degree Kelvin. If you write in this form, this is wrong, is Kelvin. And the next one we have electric current. So simply we can write down electric current, and SI base unit of electric current is ampere. In physics, mostly means at this level we will be focusing on these 5 SI quantities and SI base units, but we have 2 more. Next one is light intensity, or I can simply say intensity. Light intensity, or you can say intensity. Light intensity, the unit of this one is candela candela, we use CD for this. And the last one is amount of substance. SI base quantity is amount of substance, and its SI base unit is mole, MOL. This is the symbol. So these 7 SI base units we can use to express unit of any other physical quantity in terms of these units. So that's the reason we call them SI base units. Now let's try to answer this question. We need to find SI base unit of K. For K, it is given to us that FV, this is equal to KRV. From here simply we can write down K is equal to FV over RV. For force, first of all, we can write down SI base units. Force is equal to MA. So the SI base units for force are kg meter per second. And we can also write down SI base unit for R. Radius, SI base unit is meter. And for velocity, we can also write down SI base unit. That is meter per second. Now simply we need to plug in here. For force, we can write down this is kg meter per second, and this is divided by meter, and here we have meter per second. Now we can simplify this meter we can cancel with this meter. Now we can write down this is kg per meter, and here we have per second. So this is SI base unit of K. This question has 2 marks. The first mark you will get if you have written SI base unit for the force, and that is C1 mark. If you have written this one, you will get 1 mark. And the second mark is the answer mark. If you have got the right answer, you will get 2nd mark. But if your answer is right, you haven't written this step, still you will get 2 marks. For part B, question is asking us to use the value of the upthrust acting on the sphere to calculate the density of the liquid. But value of upthrust is given. If you read question carefully, it is given to us upthrust is equal to 4.8 times 10 to negative 4. Simply we can say upthrust is given to us, and this one is equal to 4.8 times 10 to negative 4 newtons. Radius of the sphere is also given, so we can also calculate volume of the sphere. Volume is equal to 4 by 3 pi r cube. So we can plug in values here. This is 4 by 3 pi r cube, but r is given in millimeters, so we have to convert this one into SI units. So this is 2.1 times 10 to negative 3 cube of this quantity, means cube of radius. Density of the fluid. Density of the fluid we need to find out. So first thing, now we need to understand upthrust, this is equal to density of fluid times G times volume of fluid displaced. But in this case, our object is fully submerged. It means the volume of the fluid displaced. This is volume of fluid displaced. This is equal to volume of object. So we can say volume of fluid displaced is equal to volume of object. Why? Because object is fully submerged. So we can also write down object is fully submerged. Now simply we need to use formula and we can find out value of density. So if we rearrange this equation, we can simply write down density of fluid is equal to upthrust divided by G times volume of object. Upthrust, we have the value of upthrust is 4.8 times 10 to negative 4 divided by G, that is equal to 9.81, and we have volume that is equal to 4 over 3 pi r cube, that is 2.1 times 10 to negative 3 cube of this. Now simply we need to solve this. If we solve this one, we can get value of density, and in this case value of density up to 2 SF, this is equal to 1300 kilograms per cubic meter, means up to 2 SF. Why do we need to use 2 SF? If you look at the raw data, means given data, this has 2 SF, so this has 2 SF, and this one has 3 SF, this one has 2 SF. So our final answer, we use least number of SF, least number of SF in raw data, least number of SF, simply I can say in given data. That's the reason in our final answer we are using 2 SF, because in the given given data, least number of SF is 2SF. So this is also 2SF. And this is 3SF. So our final answer as 2SF equal to least number of SF in given data. So our final answer for this question is 1300 kilograms per cubic meter. You also need to keep an eye on the given units. So our answer has to be in SI base units in this case. So this is our final answer. You will have 3 marks in total. The first mark you will get if you have calculated volume. So you will get first C mark. And the second C mark you will get if you have rearranged this formula to calculate density. So this is second C mark. And the final mark is answer mark if you have got the right answer. That if your answer is wrong, you have written these 2 steps, still you will get 2 marks. For part C1 on the sphere in figure 1.1, we need to draw 3 arrows to show directions of the weight, upthrust, and the viscous force. Label these arrows W, U, and FV respectively. It means for weight we have to use symbol W, for upthrust we have to use U, and for viscous force we have to use FV. Now if you look at this sphere, the weight means the force of gravity is always acting downwards. It doesn't matter sphere is moving or not. So this is direction of W. Weight is acting down. Upthrust always acts upwards. It doesn't matter sphere is moving or it is at rest. So this is direction of upthrust, means upthrust is acting upwards. Now we need to understand what is direction of viscous force. Direction of viscous force, it depends on direction of motion. In this case, sphere is moving downwards. It means viscous force is acting in opposite direction. So the viscous force has to be acting upwards. So this one we can simply say this is FV. So this is direction of viscous force. This is all what we need to do for part 1. And if you have drawn these arrows, you will get 1 mark. This part has only 1 mark. For the second part, we need to determine the magnitude of the terminal velocity of the sphere. Terminal velocity means the constant velocity. If the velocity of the sphere is constant, it simply means that the resultant force acting on this sphere is equal to 0. Now in this case, you can see the downward force is weight. So in this case, weight is equal to upthrust plus FV, means the viscous force. Upthrust plus viscous force, I'm just writing FV, viscous force. If we have value of viscous force, then we can find out the value of V. So if we rearrange this one, we can write down FV is equal to weight minus upthrust. But for this question, we have value of the weight. Weight of the sphere is given, so this is value of the weight. Weight is equal to 7.2 times 10 to negative 4, and value of upthrust is also given in this question, and that is equal to 4.8 times 10 to negative 4. And from here we can find value of viscous force FV. If we solve this one, our answer in this case will be 2.4 times 10 to negative 4 newtons. So this is value of FV. In this question, it is also given to us that FV, this is equal to K times V times R. And V is the terminal velocity, and this is Vt. This is what we need to find out. So simply we can rearrange. So Vt in this case will be equal to Fv divided by K times R. Fv, we have the value of Fv, that is equal to 2.4 times 10 to negative 4, and value of K for this question is also given, that is equal to 17. K is a constant, its value is equal to 17. R is the radius, and radius of the sphere in this question is given, that is equal to 2.1 mm. So simply we can write down 2.1 in SI base units, 2.1 times 10 to negative 3 meters. Now simply we need to solve this one and we can find out value of velocity. So in this case, if we simply plug in values, we will get 6.7. So this is 6.7 times 10 to negative 3 meters per second. So this is value of terminal velocity. And this question has 2 marks. The first mark you will get if you have got the right value of Fv. So this is first C mark. And this is the answer mark. If you have got the right answer, you'll get this mark. But if your answer is wrong, but you have written this step, still you will get 1 mark. Welcome to A-Level and AP Physics. In today's lesson, we will discuss one very important past paper question on kinematics from March 2022, paper 2. In this question, we will discuss what is difference between distance and displacement and how to calculate total displacement of any object that is projected horizontally. And we will also discuss why the horizontal velocity of projectile does not change if there is no air resistance. For question number 2, it is given to us water leaves the end of a hose pipe at point P with a horizontal velocity of 6.6 meters per second. This is horizontal velocity. It is also given to us point P is at height h above the ground. So this is height h. The water hits the ground at point Q. At this point, water hits the ground. The horizontal distance from P to Q is 3.5 meters. So this is horizontal distance. It is also given to us air resistance in this case is negligible. And the only force that is acting on each droplet is its weight. Now for part A, we need to explain briefly why the horizontal component of the velocity of droplet remains constant as it moves from P to Q. Now in this case, simply we need to understand velocity remains constant if there is no net force acting on the object, or simply you can say acting on the body. And in this case, there is no force acting along horizontal, so it simply means that a horizontal velocity remains constant. So simply we can say along horizontal, simply we can write down here, along horizontal there is no net force acting. So simply we can say along horizontal F net is equal to 0. So it simply means that A is equal to 0. Horizontal acceleration is 0. So it means that delta V is equal to 0. So that's the reason the horizontal component of velocity remains constant, because there is no force on droplet of water in horizontal direction. So that's all what we need to write down. Imagine that if there was air resistance, for example, then you will see air particles like this. So imagine that if there was air resistance, then what will happen? So you can imagine these are air particles. Now when water will be falling, water will hit, let's say this is one big droplet of water. This one hit this air particle. When it will hit air particles, it will apply force on air particle in this direction, and air particle will apply force on this one in opposite direction. So you can see this resultant force on this droplet, it has two components. One component is upwards and one is to the left. So if there was air resistance, then this air particle will decelerate along horizontal and also it will decelerate along vertical. But in this case, there is no air resistance. So the horizontal component of velocity will not change, but vertical component of velocity will change because there is gravity that is acting in downward direction. But this question is only asking us about horizontal component. So as there is no force along horizontal component, so it simply means that horizontal component will remain constant. So simply you can say no force along horizontal, no net force, better to say no net force. So delta V is equal to 0. So let me show you how you can write down the answer. This is how you can write down the answer if you have mentioned this point, because force on droplet of water in horizontal is 0. So this is the main point. If you have written this one, you will get one. For part B, we need to show that the time taken for a droplet of water to move from P to Q is 0.53 seconds. For this question, we have horizontal velocity. So horizontal velocity is given to us, and horizontal displacement is also given. So simply we can consider horizontal motion and we can find out value of time. So in this case, we are talking about horizontal motion. For horizontal motion, we can write down horizontal displacement. This will be equal to ux times time plus 1/2 ax t square. But in this case, ax is equal to 0 because there is no resultant force acting along horizontal. So ax is equal to 0. So simply we can write down, in this case, horizontal displacement is equal to ux times t times time, because ax is equal to 0. So it means this term is equal to 0. Now we need to find out value of t. So we can rearrange this. We can write down horizontal displacement divided divided by horizontal component of velocity. Horizontal displacement in this case is 3.5 meters. Simply we need to divide this one by horizontal velocity. That is 6.6 meters per second. So our final answer in this case will be 0.53 seconds, and this is the answer. This question has only 1 mark. If you have got this right answer, you will get 1 mark. For part C, we need to calculate height. It simply means that we need to consider vertical motion now, because height is the vertical displacement. So we have to consider for this part vertical motion. For vertical motion, we need to understand the initial velocity of this object, means water, is only horizontal velocity. So it has no velocity along vertical. So we will say initial vertical velocity. We can simply say uy. This one is equal to 0. And the time taken from this point to the ground, from P to ground, or time taken from P to Q, it is the same. So we can simply say time taken is 0.53 seconds. You also need to understand time taken depends on height. Time taken does not depend on horizontal displacement. Let's try to understand this one with this equation. Time taken for horizontal motion, this is equal to Sx over Ux. If we increase the initial horizontal velocity, horizontal displacement will increase, but time will stay same if there is no air resistance. We are talking about ideal case, no air resistance. So we are talking about ideal case when no air resistance. If no air resistance, if you increase Ux, Sx will increase, but time taken will stay same if height is the same. So we are saying if height is the same, height is same means we don't change the height, time taken will be the same if we change the horizontal component of velocity. Imagine that in this case we increase this velocity to 8.0 meters per second. So in this case the horizontal displacement will increase. So maybe ball will reach this point. So we can say this is Q prime. But time taken still will be the same because it is independent of horizontal component of velocity. Very important point. They can ask you this one next time in a different way. Now the next thing we need to understand, along vertical there is acceleration that is due to gravity, and the value of that one is 9.81 meters per second per second. We need to find out vertical displacement. It simply means we need to find height. In this case acceleration is constant, so simply we can use S is equal to ut plus 1/2 a t square. And in this case we need to choose one direction. Now we will take downwards as positive. If we take downward positive, it means acceleration is positive and value of displacement also will be positive. U in this case is equal to 0, so simply we can say this is equal to 0 plus 1/2 a is equal to 9.81 and time is 0.53. So if you do this calculation, our final answer will be 1.4 meters. And this is height, means this is the vertical displacement. Our answer has 2 SF because in the given data, least number of SF we have 2. So this has 2 SF. So our final answer also have 2 SF. So this is our final answer. And this question has 2 marks. The first mark is C mark if we have used this equation. So this is the C mark. And the second mark is answer mark if we have done these calculations correctly. You will get the second. So 2 marks for this question. For final answer we can write down 1.4. Unit is given this meter. For the movement of a droplet of water from P to Q, state and explain. State and explain. Very important. You have to state, then you have to also explain whether the displacement of the droplet is less than, more than, or the same as the distance along its path. So the first thing we need to understand, what is displacement? Displacement is the shortest distance between any 2 points. In this case, displacement from P to Q, this is the displacement. So this straight line is the displacement from P to Q. And you see this curve, this one is the distance. So simply you can see from here, in this case, displacement is less. So we will state displacement is less than distance. So simply you can say this is the statement you have given. Displacement is less than distance. Why it is less than? Now you need to explain. So here you need to write down the explanation for that. You need to explain. Because displacement is a straight line distance, you can simply say because displacement is a straight line distance. Straight line distance from P to Q. So this is our explanation from P to Q. From P to Q. So this is how you can answer. Let me show you a proper answer for this question. For this question, simply you can say displacement is straight line distance from P to Q. So less than distance along the path. So this one is over distance. So let me highlight. Maybe some student, they will not be clear what exactly it means by distance. So this one is the distance. This blue line, this one is the distance. So this is distance. This one is distance and this one is displacement. So this one is displaced. So in this case, displacement is less than distance because displacement is a straight line. And this question has only 1 mark. If you have written less and then you have explained, you will get this mark. For the last part, we need to calculate the magnitude of the displacement of water droplet that moves from P to Q. Means we need to find out the displacement from P to Q. The total displacement, I will simply say. So this one is displacement. For this question, we have already calculated vertical displacement. So this is our vertical displacement. And the value of this one is 1.4 meters. Now simply we need to find out value of total displacement. And this is just a right angle triangle. So simply we can say in this case, net displacement will be equal to 3.5 square plus 1.4 square and also the square of this. Or simply we can say this will be equal to 3.5 plus 1.4 and we can take the root of this. So the final value of displacement we can find out. So this is our displacement. So displacement in this case will be equal to 3.8 meters. And this question has 2 marks. If we have written the first one, you will get 1 mark and this is C mark. And the second mark is answer mark. If you have got the right answer, you will get the second mark as well. Welcome to A-Level and AP Physics. In today's lesson, we will discuss one very important past paper question on momentum conservation from March 2022, paper 2. I said this question is very important because you will see same kind of questions in many past papers. If these concepts are clear, means the concept you need to answer questions in today's lesson, it means you have good understanding of momentum. For third question, it is given to us, a jet of water hits the vertical wall at right angles as shown in figure 3.1. The water hits the vertical wall with a velocity of 5.0 meters per second. The cross-sectional area of the jet is 1.5 times 10 to negative 4 square meters. The density of water is 1.0 times 10 to 3 kilograms per cubic meter. The water runs down the wall after hitting it. Means simply water goes down, as you can see here. We need to find out, for this question, for part A, we need to show that over a time of 1.6 seconds, mass of water hitting the wall is 1.2 kilograms. Now the first thing we need to understand how we can calculate mass. Mass is equal to density times volume. And volume simply is equal to A times L. Because the shape of the jet of water is cylindrical, is like a cylinder, and this is the cross-sectional area of the cylinder. If we can find out the length of the cylinder in 1.6 seconds, then we can find out the volume of water reaching the wall. And volume of water is equal to A times L. So rho times A. But the problem is that how we can find out L, the length of cylinder. But in this case, length of cylinder, this is equal to the distance traveled by water in given time, and distance is equal to u times t, means the velocity times t. Velocity of water is constant in this case, so simply we can replace L with ut. L is equal to ut. So simply we can write on here L is equal to ut. We need to plug in values. Density of water is 1.0 times 10 to 3. This is given. Cross-sectional area is given. That is equal to 1.5 times 10 to negative 4, and velocity is given, that is 5.0 meters per second. So we can write down velocity here, and the time for time 1.6 seconds. So this is value of time. Now if we simplify, our final answer will be 1.2 kilograms, and this is the final answer. This question has 2 marks, and the first mark will be given to you if you have written this formula. Density means the mass is equal to density times volume. Mass is equal to density times volume. And the second mark you will get if you have done these calculations and you have got the right answer, and this is answer. But if your answer is wrong, you have written this step, still you will get 1 mark. For part B, we need to calculate the decrease in the horizontal momentum of the mass of water in A due to heating the wall. But if we look at this question, it is given to us the initial momentum it has, that is to the right. So it has initial momentum to the right because it has initial velocity that is to the right. But if we look at velocity after hitting the wall along horizontal, it has no velocity. So we can say V along horizontal after hitting the wall, this is equal to 0. If the velocity after hitting the wall along horizontal is equal to 0, it simply means that its final momentum along horizontal is also equal to 0. Now question is asking us to calculate decrease in horizontal momentum. So simply we can calculate change in momentum, and change in momentum is equal to final momentum minus initial momentum. In this case we are taking to the right as positive, so to the right is positive. Final momentum is equal to 0 because the final velocity is 0. We can also write down this will be equal to mv minus this will be equal to mu. In this case final velocity is equal to 0, it means the final momentum is equal to 0. So this is minus mu. M we have calculated in part A, that was equal to 1.2, and the initial horizontal velocity is 5, and this 5 is positive because we are taking to the right is positive. Our final answer in this case will be equal to 6.0 Newton second, but here we will get negative sign, and negative sign simply telling us that the change in momentum is negative, or simply you can say this negative sign is telling us decrease in momentum because the change is negative. It means momentum decreases. So this is decrease because change in momentum is negative. So our final answer for this question is 6.0 Newton second. This negative sign is representing decrease. For the second part, question is asking us to calculate magnitude of the horizontal force exerted on the water by the wall. Now if you look at this situation, in this case water will exert force on the wall. So here we can draw, this is the force on wall by water. So this is force on wall by water. We can say this one is action force. So wall will also exert force on water. So simply we can draw force exerted on this jet of water by wall. So this is the force on water, mean on jet of water by wall. So this one is reaction force. Action and reaction forces. This question is asking us to calculate magnitude of that force. So the resultant force exerted on water by the wall, we can simply find out that one will be equal to change in momentum over time. For this question we have already calculated change in momentum along horizontal, that was equal to 6.0, and the time taken was given, that was equal to 1.6. Mean this momentum change takes place in this period of time. So we can find out the value of force. Simply we need to divide. If we divide this one, our final answer will be 3.8 newtons. So this is the force exerted on the water by the wall. So the magnitude of this force is equal to 3.8 newtons, and the magnitude of this force is also equal to 3.8 newtons because these are action and reaction forces. So our answer for this question is 3.8 newtons, and this question has only 1 mark. If you have got the right answer, you will get this mark. For part C, we need to state and explain explain the magnitude of the horizontal force exerted on the wall by the water. First thing we need to state, so simply we can say the magnitude of this force means the force on the wall by water. Magnitude of this force is equal to 3.8 newtons. Now we need to explain why this is equal to 3.8 newtons. We can say because force on the wall by water is equal to force on water by wall. Force on water by wall. We can also add negative sign here because their direction is opposite. By Newton's third law. Because these two forces, they form Newton's third law pair. So we can say by Newton's third law. They form Newton's third law pair. So Newton's third law pair. Or we can simply say these are Newton's third law pair forces. That's all what we need to say. Simply if you mention by Newton's third law, you will get 1 mark. This question has only 1 mark. For part D, we need to calculate the pressure exerted on the wall by the water. So pressure P simply is equal to force exerted on the wall divided by contact area. So this one is contact area. So this one is contact area. Now in this case, force we have already calculated. That is equal to 3.8 newtons. And the contact area is equal to the cross-sectional area of jet of water. Means if you look at the wall, this one is the contact area. And contact area simply is equal to cross-sectional area of the jet. And that is 1.5 times 10 to negative 4. Now if we simply solve this one, our final answer will be 2.5 times 10 to 4 Pascal, or you can say newtons per square meter. Pascal. So this is our final answer, 2.5 times 10 to 4 Pascal. This question has 2 marks. The first mark you will get if you have written this formula, and that one is the C mark. And the second mark is answer mark. If you have got the right answer, you will get second mark. Welcome to A-Level and AP Physics. In today's lesson, we will discuss one very important past paper question on work, energy and power. And this question is from March 2022, paper 2, variant 2. In this question, we will discuss some key concepts about work, energy and power. And those concepts are very important to understand this topic in a proper way to answer past paper questions. For question number 4, it is given to us a child moves down a long slide as shown in figure 4.1. The child moves from rest at the top, means at this point speed of the child is equal to 0. As speed of the child is equal to 0, we can also say initial kinetic energy of the child is equal to 0. It is also given to us resistive force of 76 newtons opposes the motion of the child. Kinetic energy of the child at point Y is 300 joules. So at this point we can say kinetic energy final, this is equal to 300 joules. So this is equal to 300 joules at point Y. But decreasing gravitational potential energy is also given, that is equal to 3200 from X to Y. Means when this child moves from X to Y, the decrease in gravitational potential energy means delta GPE. This is given to us and the value of this one is 3200 joules. Now if we take Y as our reference line and we assume at this point H is equal to 0, so we can say final GPE is also equal to 0. So simply we can say final GPE is equal to 0. So we can say initial value of GPE means at point X, this is equal to 3200 joules. For part A, question is asking us to determine the ratio between kinetic energy of the child child at Y when the resistive force is 76 newtons, and kinetic energy of the child at Y if there is no resistive force. For this question, first thing we need to understand is kinetic energy of the child when there is resistive force. That kinetic energy is given to us, and the value of that kinetic energy is equal to 300 joules. So this value we have. Now we need to find out kinetic energy of the child at Y if there is no resistive force. For that purpose, we will use conservation of energy. So we will use this principle of conservation of energy, and we will try to find out. We can find this directly, but to give you better understanding, I will apply conservation of energy. Now, if we apply conservation of energy at this point at X, so the total energy at X has to be equal to total energy at Y. If there is no resistive force, it means mechanical energy is conserved. We can simply say mechanical energy at X has to be equal to mechanical energy at Y. Mechanical energy simply means that kinetic energy initial plus gravitational potential energy initial. This one has to be equal to kinetic energy final plus gravitational potential energy final. Kinetic energy initial is equal to 0. So simply we can say this is equal to 0. And GPE initial is equal to 3200. KE final we need to find out, means the value of KE at point Y, and GPE final at Y is equal to 0. So the KE final is equal to 3200 joules when there are no resistive forces. So simply we can write down this is 3200. We need to find the ratio between them. Simply we need to divide. If we divide this one, our final answer is going to be 0.094, and this is our final answer. And this question has only 1 mark. If you have got the right answer, you will get this mark. For part B, we need to use the answer in part A to calculate the ratio between the speed of the child at Y when the resistive force is 76 newtons and speed of the child at Y if there is no resistive force. In part A, we have calculated ratio between kinetic energies when there was resistive force and when there was no resistive force. Now question is asking us to calculate the ratio between speeds. In order to answer this question, let's start from kinetic energy. Kinetic energy of a body is equal to 1/2 mv square. We need to find the ratio between speeds, so we can simply rearrange kinetic energy over speed square. This is equal to 1/2 m. But if the mass of the body is not changing, if we're talking about the same body with constant mass, means mass of the body is not changing, we can simply say that the ratio between kinetic energy and v square will stay constant. And this is true for this case. When the child is moving from X to Y, the mass of the child is not changing. So simply we can say 1/2 m is equal to constant. If this is true, we can also say kinetic energy, means the ratio between kinetic energy when there are resistive forces and speed square when there are resistive forces has to be equal to kinetic energy over v square when there are no resistive forces. Now if we cross multiply, means we multiply like this, we cross multiply now, so we can say kinetic energy R times v square. This one has to be equal to kinetic energy times VR square. We need to find the ratio between VR and V, so we can divide this side by V square times KE. So we need to divide this side by V square times KE. Now in this case, simply you can see we can cancel out kinetic energy with kinetic energy, and we can cancel out V square with V square. So simply we left with KE R divided by KE. This is equal to VR square divided by V square. But we have the ratio between KER over KE already. That was equal to 0.094. And this is coming from part A. And this is equal to VR square by V square. We need to find the ratio between VR over V. So we can take square root on both sides. Means we have to take the root of this 1/2. Now if we simply solve this, we will get our final answer that will be equal to 0.31. So this is the answer. This is the ratio between speeds when there are resistive forces and when there are no resistive forces. And this question has 2 marks. First mark you will get if you have written this relationship. So that mark is C mark, KE over V square. You will get 1 mark. Then the second mark you will get if you have got the right answer, and this is answer mark. For part C, we need to calculate the length of the slide from X to Y. But for this question, the resistive force acting on the child is given to us, that is equal to 76 newtons. It is also given to us the value of KE at X means K initial, this is equal to 0. And GPE initial for this question is also given, that is equal to 3200 joules. At point Y, GPE is also given, that is equal to 0. And this is final value of gravitational potential energy, because we are taking Y as our reference point, and at this point we are assuming H is equal to 0. So that's reason GPE final is equal to 0. And kinetic energy at Y is also given to us. We can say this is kinetic energy final, and this is equal to 300 joules. Now simply we need to use conservation of energy to calculate work done by friction. So we will be using conservation of energy. In this case, we cannot use conservation of mechanical energy because there are resistive forces. So we have to use conservation of energy. Means we have to consider work done by resistive forces. At point X, kinetic energy initial, we can say this is kinetic energy initial plus GPE initial. This one has to be equal to kinetic energy final plus GPE final plus work done by resistive forces. Kinetic energy initial is equal to 0 and GP initial is equal to 3200. Kinetic energy final is equal to 300, but GPE final is 0. So here we have work done by resistive forces. So from here we can find out work done by resistive forces. That one will be equal to 2900 joules. So this is the work done by resistive forces, and work done by resistive forces is equal to resistive force times the distance traveled. So we can say distance traveled, and distance traveled is equal to the length of the slide. So simply we can calculate from here D, and this is length of slide between X and Y. So we can say this is length of slide. Now we need to find D, so simply we can say this is work done against resistive forces divided by, in this case we have FR. So simply we can say this is over resistive force. So value of work done against friction or against resistive forces is 2900. We need to divide by resistive force, 76 newtons. So in this case our final answer is 38 meters to SF. So up to SF our answer is 38 meters. And this question has 2 marks. First mark you will get if you have calculated work done against resistive forces, means work done against friction in this case. And the final mark is answer mark. You will get final mark if you have got the right answer. For part D, it is given to us at end Y of the slide, the child is brought to rest by a board as shown in figure 4.2. We have already discussed at point Y, kinetic energy of the child is equal to 300 joules. Now in this case, the child will use this kinetic energy, and this kinetic energy will be converted into EPE, means elastic potential energy. And the value of elastic potential energy is given to us, that is equal to 140 joules. So we can say this is equal to 140 joules. When child will press this spring, so let's say compress this one to this point, so then we can say this is the compression. So this one is the compression X, and this is what we need to find out. Question is asking us calculate the maximum compression of the spring. That the maximum EPE is equal to 140 joules. So we need to find out X. For this question, spring constant is given. It is given to us the spring obeys Hooke's law, and spring constant is equal to 63 newtons per meter. We need to find X. So pretty straightforward question. Elastic tension energy is simply equal to 1 half kx squared. If Hooke's law is obeyed, so this is equal to 1 half kx squared. We need to find out X. So simply we can rearrange. We can say this is equal to 2 times EPE divided by k. We need to find x, so simply we can say x will be equal to 2 times EPE, elastic potential energy divided by k. If we take root of this will be equal to x, means this will be equal to maximum compression, because we are using maximum value of EPE. So this is our x max. Now simply we can plug in these values. EP is equal to 140, k is equal to 63 newtons per meter, and our final answer will be 2.1 meters. So this is our final answer. Main spring will be compressed by this much, 2.1 meters. And this question has 2 marks. The first mark you will get if you have written this formula. So this is C mark. And the second mark is answer mark. If you have got the right answer, you will get the second mark. For the second part, we need to calculate the percentage efficiency of the transfer of the kinetic energy of the child to elastic potential energy of the spring. So simply we can write down here kinetic energy of the child, means how much kinetic energy of the child has been converted into elastic potential energy of the spring. We need to calculate percentage efficiency for this energy transfer. Kinetic energy of the child we have that is equal to 300 joules, and elastic tension energy is only equal to 140 joules. So simply we can say part of kinetic energy has been transferred into other forms of energy. So other form of energy can be thermal energy, and this is wasted form of energy. So we can simply write down thermal energy, and this is wasted form. So this is wasted form of energy. And this one is useful. So simply we can say this one is useful. Now we need to find the percentage efficiency. So simply we can say percentage efficiency is equal to useful energy output. So we can say useful energy out. Energy output divided by total input. Then we need to multiply this one with 100. In this case, useful energy output is EPE, that is equal to 140, and input energy is equal to kinetic energy. We have to multiply this one by 100. If you multiply by 100, our final answer will be 47%. And this is the answer. And this question has only 1 mark. If you have got right answer, you will get answer mark. For the last part, it is given to us the maximum compression of the spring is X naught. On figure 4.3, we need to sketch a graph to show the variation of the elastic tension energy of the spring with its compression x from x is equal to 0 to x is equal to x naught. Numerical values are not required. So first thing we need to understand elastic tension energy. Elastic tension energy is equal to 1 half kx squared. When x is equal to 0, EPE has to be equal to 0. So means the first point has to be here. It has to be 0. We have to start from origin. And when x is equal to x naught, EPE is maximum. So it has some value, maximum value. But we also need to understand EPE is directly proportional to x squared, because 1 half k, this is constant. So this is constant, and this spring obey Hooke's law. So simply we can say EPE is directly proportional to x squared. So the shape of the graph has to be parabolic, or simply we can say the gradient of the graph has to increase with x. So gradient has to increase. So simply we can sketch the shape of the graph has to be parabolic, increasing gradient. So simply you can sketch graph like this. If you have sketch like this, it has to be curve. You will get 1 mark, curve from origin. So this is the first mark you will get. And this mark is M mark. It has to be curve. If you draw straight line, you will get 0 mark. And the second mark is if the gradient is increasing. So you will get 7 mark. And that is answer mark. So 2 marks for this question. Welcome to A-Level and AP Physics. In today's lesson, we will talk about stationary waves and polarization by solving past paper question from March 2022, Paper 2, Variant 2. In this class, we will discuss some important concepts about waves and polarization. For part A1, we need to state the conditions required for the formation of a stationary wave. So let's try to understand how a stationary wave can be formed. First of all, in order to form stationary wave, we need two different waves, and these two waves, they have to overlap to form a stationary wave. So simply we can say this is also required condition, and these two waves, they have to travel in opposite directions, otherwise stationary wave will not be formed. So waves have to travel in opposite directions, and this is also true if one wave is refracted wave and one is incident wave. They can also form stationary wave. Next thing we need to understand, waves, they must have same type. Means waves of same type, they can form stationary waves. It simply means that sound can form stationary waves with sound, and light can form stationary waves with light. Radio waves, they can form stationary waves with radio waves. So this is what is meant by same type. Next thing we need to understand, waves, they must have the same speed. So they must have same speed in the same medium, and also waves must have the same frequency. So we can say same frequency, same type of waves with same frequency and same speed in the same medium traveling in opposite directions. When they overlap, stationary wave will be formed. So these are the conditions we need. So if you write down these one, you will get 2 marks. This question has only 2 marks. The first mark you will get if you have written overlap traveling in opposite directions. So if you write down this one, you will get 1 mark. And if you write down same type, same speed and same frequency, you will get a 2nd mark. So this is for the sake of this question. This is how you can write down the answer. Now let's try to understand stationary waves with the help of animation. First of all, please look at this animation carefully and try to understand what is happening, and then I will highlight the important points you need to understand about stationary waves. If you have watched this animation carefully, in this case you can see there are 3 different types of waves. One is incident wave. This yellow wave, this is the incident wave. So I will write down here the yellow wave, this is the incident wave, and this wave is traveling to the right. So this one is incident wave. We will look at this animation again. So this is the incident wave, and the blue wave, this one is reflected wave. So simply I will write down here, this one is reflected wave, and this wave is traveling to the left. But if you look at green wave, this is the resultant wave of incident and reflected wave. So we can simply say this one is stationary wave. But if you look at this point, at this point you can see the blue wave, this has negative displacement, and the yellow one, this has positive displacement. So at this point we have node. So the node is formed at this point. So the particle at this point has no displacement. Now simply we can say the particle at nodes stay at rest. So particle here, it will stay at rest. Now let's see this animation again. Now you can see here particle at this point will stay at rest because there is no displacement at this position. So this particle stay just at rest. Let's try to find out an other node. If you move to this point, so you can also see here particle at this point is not moving at all. Mean the displacement of the particle at this point is equal to 0. So let me draw a line here so you can see what is happening at the node. So this is over another node. So this is another node. So you can see displacement at this point is 0. And if you look at this point, displacement is also 0. Now you have to look at stationary wave only. wave. So I will hide in this case incident and reflected wave. So if you look at stationary wave, you can see between any two nodes, all the particles at the same time they will go down, and at the same time then they will reach the peak and they will continue moving in this cycle. So the particles between two consecutive nodes, they are in phase. So simply we can say particle between two consecutive nodes, they are in phase. So very important point. So in phase. So all the particles between two consecutive nodes, mean between this point and between this point. We can also use letter N here. So this is node and this is node. So all the particles between any two consecutive nodes, they are in phase. So the particles between these two consecutive nodes, they are in phase. So this is what you need to understand about stationary waves. I hope it is clear to you. Let's see all the waves again now. So you can see how incident and reflected wave, they overlap and they form the stationary wave. So incident and reflected wave, they have to be of the same type. They should have the same speed in the same medium, and they should have same frequency, and they need to overlap, and they need to travel in opposite directions. This is how we can write down our answer for part A1. Now let's move on to second part. For the second part, we need to state the phase difference between any two vibrating particles in a stationary wave between two adjacent nodes. So first of all, let's try to sketch a stationary wave. Let's say this is our stationary wave. So this one is stationary wave. In this case, you can see we have node here. We also have node at this point. So this is one node, this is an other node, and this is an other node. In this case, all the particles between these two nodes, let's say these particles are moving down. So all the particles, they will move down at the same time, and at the same time they will reach the lowest point, and then again they will start moving up. So all the particles between two nodes, they are always in phase. So we can say these particles are always in phase. If particles are in phase, we can simply say in that case, phase difference is equal to 0. So phase difference is equal to 0. So this is what you have to write down for this question. So simply you can say 0. Phase difference is 0. But if you look at particles between next two nodes, so when these particles, they are at the peak, these particles, they will be at the lowest point. And after that, they will start moving up. So particles here and particle here. Let's say we have particle X. So let me explain a little bit more about that. Let's say we have one particle here. Let's say this is particle X. And let's say we have one particle here, that is particle Y. X and Y, they are in antiphase. So we can say X and Y, they are in antiphase. So these are in antiphase. If we take other particles, for example, particle at this point, let's say this particle is P, and we take another particle, let's say anywhere you can take. So I will just say, let's say at this point, let's say this particle is R. So P and R, they are also in antiphase. So they are also in antiphase. If we take another particle, let's say we take particle here, let's say this particle is S, and we take another particle here, this particle is T. So S and T, they are also in antiphase. So we can say S and T. So T and R, S and T, they are also antiphase. Means the phase difference between them is equal to 180 degrees. It simply means that when this particle is moving down, these particles will be moving up. For part B, it is given to us a motorcycle is traveling at 13 meters per second along a straight road. The rider of the motorcycle sees a person standing in the road directly ahead and operates a horn to emit a warning sound. The person hears the warning sounds at a frequency of 543 Hz. The speed of the sound in the air is given. We need to calculate the frequency to 3 significant figures of the sound emitted by the horn. This question is about Doppler effect, and in this case, source is approaching. So simply we can label this is motorcycle. In physics, if you don't want to draw something, you can simply will label that. So this is motorcycle, and this motorcycle is approaching an observer, and this observer is at rest, and speed of the motorcycle is given, means speed of the source is given, that is Vs, and Vs is equal to 13 meters per second. In this case, source is approaching, so we have to use Doppler effect for approaching source, approaching. So observed frequency simply will be equal to speed of the wave in that medium divided by speed of the wave. In this case, source is approaching, so it has to be negative because observed frequency has to be greater than frequency of the source. In this case, this frequency is observed frequency because this is the warning sound heard by the person. So this is our observed frequency. We have to find out Fs. So simply we can plug in values here now. Again, we can write down this is observed frequency. This is equal to speed of the wave, mean this is speed of the wave in that medium, divided by speed of the wave minus speed of the source, multiply with frequency of the source. Observed frequency in this case is given, that is equal to 543 meters per second. Speed of the wave is given, this is 334, so again we have to write out here, and speed of the source is given, that is 13, and we have to find Fs. Now simply if we solve this, we can find out frequency of the source, and frequency of the source up to 3SF will be equal to 522 Hertz, and this is right answer because in this case source is approaching, so the observed frequency has to be greater than frequency of the source, or we can say Fs has to be lower than observed frequency. So this is our final answer. We can write on here 522. This question has only 2 marks. You will get 2 marks if you have plug in values, means you have sub values, right values, and you will get 1 mark, and the final mark is answer mark if you have got the right answer. For the second part, it is given to us the motorcycle rider passes the stationary person and then moves directly away from her. As the rider moves away, he operates horn for a second time. The person now hears the sound that is increasing in frequency. It simply means that observed frequency is increasing. We need to state the variation, if any, in the speed of the motorcycle when the rider operates the horn for the second time. So the first thing we need to understand, in this case, source is moving away. So simply we can write down, first of all, source is moving away. Means observer is standing here, observer is at rest, and the source is moving away. So this is our motorcycle that is moving away, and motorcycle is the source. Motorcycle is moving away. Now we need to understand how we can write down Doppler effect for a moving source that is moving away from observer, means from stationary observer. So observed frequency in this case will be speed of the wave divided by speed of the wave plus speed of the source. Then this has to be multiplied with frequency of the source. Now in this question, it is given to us that frequency is increasing. When observed frequency is increasing, but frequency of the source is same, is constant. Frequency of the source is constant, speed of the wave in the same medium, same wave, same medium, so speed is the same because speed of the wave depends on type of wave and medium, so that is the same. Now if F not increase, it simply means that speed of the source is decreasing. So simply you can understand from here, this is a special case when the speed is decreasing. So if the speed is decreasing, observed frequency will increase. If speed increase, you will see observed frequency will decrease with time, means frequency will not be constant. If the source is moving at constant velocity, observed frequency is constant, but if the source is slowing down, observed frequency will increase. But if the source is speeding up, observed frequency will decrease. Mean if this increase, so I will be using dotted line, if this increase, observed frequency will decrease. So simply for this question we need to understand speed of the source is decreasing, so we can say speed is decreasing. And this question has only 1 mark. So simply you need to write down speed is decreasing and you will get 1 mark. And this is B mark. For part C, it is given to us a beam of vertically polarized monochromatic light is incident normally on a polarizing filter, as shown in figure 5.1. So in this case, you can see we have vertically polarized light, means this is vertically polarized light. So this is vertically polarized light. And here we have polarizing filter that is placed in front of that. And the angle between vertically polarized light and transmission axis is 20 degrees. And here we have over transmitted light. So this will be transmitted light. Intensity of transmitted light is given, that is IT. Question is asking us to calculate the ratio between amplitude of transmitted light and amplitude of incident light by considering the ratio between IT and I naught. And we need to show overworking. Means we have to write down all the steps. So we can start this one from intensity. Mean the relationship between intensity and amplitude. Intensity is directly proportional to amplitude squared. From here we can also say that intensity over A naught square means the ratio between these two remains constant. So we can say this is constant. So in this case, we can also say that intensity of incident light over amplitude of incident light square, this will be equal to intensity of transmitted light over amplitude of transmitted light square. If we rearrange this one, we can write down IT over I naught. This one will be equal to AT square over A naught square. We have to find the ratio between these two. So we can also write down here that AT over A naught square, here we have square, this is equal to IT over I naught. Or we can say AT over A naught, this is equal to IT over I naught square root of that. Means the power of this one is 1 by 2. Now we need to find out what is the ratio between IT and I naught. And the power of that one will be equal to 1 by 2. So let's try to find out the ratio between IT and I naught. For that purpose, we have to use Malice's law. According to Malice's law, IT means intensity of transmitted light. So we can say transmitted light, IT transmitted. This is equal to intensity of incident light. So I will be writing I naught here for incident times cosine square theta. Theta is the angle between vertically polarized light, meaning the polarized light, and transmission axis. And angle in this case is given, that is equal to 20 degrees. So we can say this is cosine square 20 degrees. Now from here we can write down IT over I naught. This is equal to cosine square of 20 degrees. We can solve this one and we can find out value of this. Now we have found the ratio between IT over I naught. So simply we will plug in here. So IT over I naught is equal to cosine square of 20 degrees. Now if we simplify this one, we can cancel this power with this. Means we can cancel this 2 with this 2. So simply we left with AT over A naught. This is equal to cosine of 20 degrees. And simply now we can use calculator and we can find out value of cosine 20 degrees. And cosine of 20 degrees is equal to 0.94 up to 2 SF. And this is our final answer. This question has 3 marks. You will get the first mark, that is B mark, if you have written the relationship between intensity and amplitude. Means if you have mentioned this one, you will get first mark, that is B mark. And the C mark you will get if you have written this step, you will get the C mark. And you will get the final mark, that is answer mark, if you have got the right answer. So this is answer mark. And this is how marks will be awarded for this question. For the last part, it is given to us the filter is now rotated about direction of the light beam from its starting position as shown in figure 5.1. Direction of rotation is such that angle of transmission axis through the vertical initially increases. So in this case, we need to understand this is vertical and this is transmission axis. So the angle between vertical and transmission axis has to increase initially. So if we rotate this one counterclockwise, angle between them will decrease initially. So that is not what we need to do. We have to increase the angle initially. So simply we have to rotate this one in clockwise direction. We need to calculate the minimum angle through which the filter must be rotated so that the intensity of the transmitted light returns to the value that it had when the filter was at its starting position. Let's try to understand this one with the help of Malice's law. According to Malice's law, intensity of transmitted light is equal to intensity of incident light times cosine square theta. In this case, intensity of transmitted light means IT at the starting, so we can say at starting position has to be the same as intensity of transmitted light at final position. So these two has to be the same. If IT has to remain same, I naught is fixed. So the cosine square of theta also need to remain same. So how cosine square of theta can be same? In order to understand that one, let's look at this angle first of all. In this case, first of all, angle between vertical and transmission axis is 20 degrees. Now we have to rotate this one clockwise, so the angle between vertical and transmission axis is again 20 degrees. So in this case, you can see here, if we rotate this one by this much, when this angle is again 20 degrees, it means intensity of transmitted light again will be the same. So you can see this total angle is 180 degrees. So we have 20 here, we have 20 here. So the angle we have rotated this polarizing filter, that angle is equal to 140 degrees. Because the total angle from here to here, this is equal to 180. So in this case, 140 plus 20 plus 20. This is equal to 180 degrees. So in this case, we have to rotate this filter by 140 degrees. And this is our answer. Welcome to A-Level and AP Physics. In today's lesson, we will discuss a typical type of question on electricity from March 2022, Paper 2, Variant 2. In this question, we will discuss some very important concepts, and those concepts are very common in past papers. Means those concepts are frequently asked in past papers. So try to listen carefully and try to improve your understanding of electricity. For our question number 6, it is given to us the ends of a metal resistance wire are connected to a battery of electromotive force 8.0 volts, and battery has no internal resistance as shown in figure 6.1. If we look at this figure, this is the resistance wire and this is connected across terminals of power supply. So this is our resistance wire. EMF of battery is 8.0 volts. It is also given to us the power dissipated by the resistance wire is 36 watts. We need to calculate current in the resistance wire. Let's try to write down what is given to us. So the best way to start this question is write down what is given. And this is not only true for this question, you can use this one for any problem in physics. So we will write down what is given. In this case, power dissipated by wire is given. So simply we can write down this is given to us. Now we need to find out what else we can find out from the given data. Now if you look at this wire and if we connect a voltmeter across this wire, we can find out value of V. Means the potential difference across this wire, and that potential difference has to be equal to 8.0 volts because this battery has no internal resistance. If it has internal resistance, we also need to consider internal resistance of the battery, but in this case it has no internal resistance, and these wires, these are also ideal wires, means there is no potential drop. So these are ideal wires, so there is no potential drop. So it simply means that all the potential is dropped across this resistance wire. So the radius reading on this voltmeter has to be equal to 8.0 volts. So we can write down V across wire. We also have, so value of V across wire is given to us, means the potential difference across wire, that is equal to 8.0 volts. Now we need to find out current. Now we need to understand how these quantities are linked together with current. So simply in this case you need to remember P is equal to V times I. V times I. So this is the power dissipated by wire, and this is potential difference across wire, and this is current passing through wire. Now we need to find out I passing through the wire. So simply we can say I is equal to P divided by V. So this one is V. So P in this case is 36 watts and the potential difference is 8.0 volts. So we can find out our final answer. In this case, final answer will be 4.5 amps up to 2 SF. Because our raw data has 2 SF, our final answer also must have 2 SF. So simply we can write down this is our final answer. And this question has 2 marks. The first mark you get if you have written this formula, means this equation, and this is C mark, you will get this. And the second mark is the answer mark. If you have got right answer, you will get 2 marks. Now the second part question is asking us to calculate the number of free electrons that pass through the resistance wire in a time of 50 seconds. First of all, let's try to calculate amount of charge passing through the wire in this given time. So we can simply calculate Q is equal to IT. So this is the amount of charge passing through wire in this given time. So we can plug in values of I and T. I we have calculated, that is equal to 4.5 amps, and time is given to us. This is equal to 50 seconds. Now if we solve this, our final answer is going to be 225 coulombs charge. Now we need to find out number of free electrons. Q, simply in this case we need to understand Q is equal to number of free electrons times the charge on single electron. But for this question we need to calculate number of free electrons. So simply we can say this will be equal to Q over charge on single electron. Total charge is given to us, that is equal to 225 coulombs. We need to divide by charge on single electron, and charge on single electron is equal to 1.6 times 10 to negative 19. Now if we simplify this, our final answer is going to be 1.4 times 10 to 21, and this is the number of free electrons passing through resistance wire in 50 seconds. So this is our final answer. So we can write down this is 1.4 times 10 to 21. And this question has 2 marks. You will get the first mark, C mark, if you have got the right answer for amount of charge. And the second mark is answer mark. You will get 2 marks if you have got the right answer. For the next part, we need to calculate the resistance of the wire. So how we can find the resistance of the wire? So the best way to start this one is by writing what is given to us and what we have calculated for this wire. For this wire, power dissipated by the wire is given, that was equal to 36 volts. We have also found the potential difference across wire, that was equal to 8.0 volts, and we have calculated current in this wire, and that one was equal to 4.5 amps. So now we have different options to calculate resistance of the wire. So easy way to find resistance of the wire is we can simply say R is equal to V over I. So the resistance of the wire is equal to the potential difference across wire divided by current passing through the wire. So in this case, potential difference across wire is 8.0 and current passing through this wire is 4.5. So we can find our final answer. So in this case, final answer will be 1.8 ohms. So this is the resistance of the wire. But we can also calculate resistance of the wire by using this equation. P is equal to I square times R. So we can rearrange, we can calculate R, that will be equal to P divided by I square. So in this case, power is 36 and current is 4.5. Now if we solve this, we can find out value of resistance again. That one will be equal to 1.8 ohms. We can also calculate resistance of the wire by using the relationship between potential difference, power and resistance. So P is equal to V square where V is the potential difference across wire divided by resistance of wire. In this case, we need to find resistance of the wire. So simply we can say potential difference squared divided by V. This is equal to resistance. And now simply we can plug in values. Potential difference in this case is equal to 8.0. So we need to take square of that and we need to divide by the power. So our final answer will be 1.8 ohms. So you can use any method. We have discussed 3 different methods. You can use any one of them to calculate resistance of wire. This question has 2 marks. You will get the first mark if you have used the right equation. And the second mark means the 2 marks you will get if you have got the right answer. For part B, it is given to us the metal of the resistance wire in the circuit has a resistivity of 1.4 times 10 to negative 6 ohms meter, and cross-sectional area of the wire is equal to 0.25 millimeter square. We need to determine the length of the wire. So the best way to answer this question is, first of all, write down what is given to us and what we have calculated for this question. Resistivity of the wire is given, that is equal to 1.4 times 10 to negative 6 ohms meter. Cross-sectional area of the wire is given, that is equal to 0.25 millimeter square. But millimeter square is not SI unit. So we need to convert this one into SI unit. In order to convert this one into SI unit, we need to understand 1 millimeter is equal to 10 to negative 3 meters. But for this question, we have millimeter square. So we have to square on both sides. So simply in this case, 1 millimeter square will be equal to 10 to negative 6 meter square. So we can write down here 10 to negative 6 multiplied by 0.25 meter square. Simply you can write down in a proper way. You can write down this is 0.25 times 10 to negative 6 meter square. But resistance of this wire we have already calculated in part A. Resistance of this wire is equal to 1.8 ohms. We need to calculate L, means length of the wire we need to calculate. So simply we can use the relationship between these quantities to calculate length of the wire. We need to understand resistance is equal to rho L by A. From here we can simply say L will be equal to R times A divided by resistivity. So we need to sub values here, mean we need to plug in values. So this is resistance of the wire, and cross-sectional area of the wire is 0.25 times 10 to negative 6, and we need to divide by resistivity. And resistivity is 1.4 times 10 to negative 6. If we solve this one, our final answer will be 0.32 meters up to 2 SF, because our raw data has 2 SF. So this is our final answer for this question. And this question has 2 marks. You will get first mark, C mark, if you have used the right formula. And the second mark you will get if you have got the right answer. I mean, if you got the right answer, you will get 2 marks. For part C, it is given to us the circuit shown in figure 6.1 is modified by replacing the original resistance wire with a second resistance wire. This is figure 6.1. So simply we can write on here the figure 6.1. The second wire has a greater diameter than the original wire. There are no other differences between the second wire and the original wire. By reference to resistance, we need to state and explain whether the power dissipated by the second wire is more than, less than, or the same as the power dissipated by the original wire. As in question, it is mentioned by reference to resistance. So first of all, we need to consider, is the resistance of the second wire, is it greater than the resistance of the first wire, or this resistance is less than resistance of first wire. So this is the point we need to understand. Is it greater, or is it less, or is it equal? So these things we have to consider. For the second wire, it is given to us that diameter is greater. So we can write down resistance is equal to rho L by A. And A is the cross-sectional area. We can write down cross-sectional area is equal to pi by 4 d square. The second wire has the same resistivity, and the length of the wire is also same, means resistivity of the second wire is the same, length is the same, but diameter has increased. If the diameter increase, it means resistance will decrease. So it means that resistance of the second wire is less than resistance of first wire. So simply we can say resistance of second wire is less than resistance of first wire. So this is very important piece of information about resistance. So we have to mention this one in our answer. Now we need to understand power dissipated. As the new wire is just placed across terminals of the power supply. So this is our new wire, and this is also connected across terminals of power supply. So it simply means that V is the same. So we can say V is the same, means the potential difference across wire is the same. V is the same, but the resistance is lower. So we can write down P is equal to V squared divided by R. If resistance is lower, it means the power dissipated in the wire is greater because potential difference across wire is the same. So these points simply we need to mention. So first thing we can say, in this case, power dissipated is more than the first wire. So we can say more than first wire. So this is what you need to state, more than first wire, or you can say the previous wire. So more than first wire. So this is first point you can write. And the second point we can write down as the resistivity. We can also say as resistivity is the same, L is the same, but cross-sectional area is greater. It means the resistance is lower. As resistance is lower, but potential difference is the same. So power dissipated is greater because power dissipated is equal to V squared divided by R. If this is lower, this one has to be greater because potential difference is the same. So these are the points you have to mention in your answer. Now let me show you how you can write down a proper answer. This is how you can write down your answer. In your answer, you have to mention power dissipated is greater. So this is one. The second one you have to mention as the length and resistivity are the same. Cross-sectional area is larger, so resistance is lower. And this is M mark, mean it has to be in your answer. Same potential difference across wire and lower resistance, so power dissipated is greater. For part D, it is given to us the circuit shown in figure 6.1 is modified by connecting a second battery of EMF 8.0 volts and battery has no internal resistance in parallel with the original battery and the original resistance wire as shown in figure 6.2. So this is our figure 6.2. In this case, you can see battery is connected in parallel with the previous one. By reference to the current in the resistance wire means current in this wire. We have to use this one as a reference. We need to state and explain whether the addition of the second battery causes the power in the original resistance wire to decrease, increase, or stay the same. Now, first of all, let's try to understand what is the effect of the second battery on current in this wire. So for that purpose, we need to understand Kirchhoff's second law. If we draw this loop, in this case, you can see potential difference across this wire does not change. So we can say V is equal to I times R. As potential difference across wire does not change, so it means current will also not change because resistance of the wire does not change. So simply from here we can say current in this case in this resistance wire will not change by connecting second battery. Now let's try to understand a little bit more about that. As this current in this wire is the same, but current coming from this battery, this will be I by 2, mean at this junction current I will split into two parts, and current entering the second battery also will be equal to I by 2. So at this junction we can also say current entering is I by 2, so this is also I by 2, and current leaving, this one is I. We need to understand current entering or leaving any battery is always same. So current entering this battery is I by 2 and leaving is I by 2, and it is same for the second battery. Current entering and leaving is the same, and the total current passing through this wire is still I. So there is no change in current. So simply we can say, as in this case, V across the wire is the same, I across the wire is the same, so power stays the same because power power dissipated by the wire is equal to V times I. So V is the same, I is the same, so power is the same. So we can simply write down, in this case, power stays the same. So this is how you can write down your answer. You can say power stays the same. So this is our statement. We can say power stays the same. Now we need to explain why power stays the same. We can simply say I means current in the wire is the same, and PD across wire means potential difference across wire, that is also same. So P is equal to VI, so power is also same. This question has 2 marks. You will get 2 marks if you have written right statement, means you have written this is right statement, you have mentioned power stays the same. So this is the answer mark. You will get 1 mark, but the second mark is M mark, means if you have written I is the same and you have written V is the same, and this is M mark, you must get M mark to get A mark. If you couldn't get M mark, you will also lose A mark, because first you need to get M mark and then you can get A mark. So this is must mark. First you need to get this one and then you can get A mark. Now let me show you the answer, how you can write down in a proper way. So this is how you can write down your answer. So let me clean. So this is how you can write down your answer. As you can see, this question has 2 marks. The first mark is M mark. So if you have mentioned current is the same, potential difference across wire is the same, so power stays the same. Welcome to A-Level and AP Physics. In today's lesson, we will discuss one very important past paper question on radioactivity and standard model for March 2022, paper 2, variant 2. In this lesson, we will discuss what are leptons and what kind of leptons are produced in any beta plus decay. Then we will talk about nuclear number and proton number. We will also discuss what are baryons, what is the quark composition of baryons, and how we can determine the charge on baryons. For part A, it is given to us a nucleus of sodium-22 decays by emitting a beta plus particle. A different nucleus is formed by the decay. We need to state the name of an other lepton that is produced by the decay. Question is asking us to state the name of an other lepton. If you look at this beta plus particle is positron, and positron is antiparticle of electron, and it belongs to lepton family. So this is the first lepton that is already given to us, and question is asking us to state the name of an other lepton that is produced by beta plus decay. And let's try to understand first of all beta plus decay. So here we have sodium nucleus, its atomic number is 11 and mass number is 22, and this sodium nucleus, it decays by beta plus. So simply we can say another nucleus is formed. Let's say that nucleus is Y and beta plus particle is emitted. So here we have beta plus particle, and here it has to be electron neutrino. Why this one has to be electron neutrino? Because this particle is positron, and positron is antiparticle of electron. So this is antiparticle of electron. It has lepton number -1, -1. But this nucleus, it has 0 lepton number. So in order to conserve lepton number, this has to be electron neutrino. So simply the reason is that if this one is beta plus particle, this has to be electron neutrino to conserve lepton number, and vice versa is also true. If this is particle, means if this is electron, this one has to be electron anti-neutrino. You have to be very clear about this point because they will ask you this in many ways. So we can say this is positron, and positron is antiparticle of electron. So this is antiparticle of electron. antiparticle of electron, and this is electron neutrino. So this is electron neutrino. There are different types of neutrinos: electron neutrinos, muon neutrinos, and tau neutrinos. That at AS level only you need to understand electron neutrino. So in answer you can write down electron neutrino, but still you will get mark if you only write down neutrino. Still you will get marks. So better to write down is electron neutrino, but if you only write down neutrino, still you will get the mark. So this is the mark. Next question is asking us to determine the nucleon number and proton number of the nucleus that is formed by the decay. This is beta plus decay. So the proton number will decrease by 1. So here atomic number means the proton number has to be 10. 10 plus 1, 11. It has to be same on both sides. Means proton number has to be conserved, and mass number will not change. So this will be 22. Mass number is nuclear number. So we can write down here 22, and this one is 10. And also we need to understand is, if you look at this beta plus decay, very important point. If you look at these two particles, they belong to lepton family. So you have to be clear about this one. These two particles, they belong to lepton family, and they do not feel the strong nuclear force. Lepton, when we talk about leptons, it means we are talking about lighter particles. So these are lighter particles, and they do not interact with strong nuclear force, or simply we can say they do not feel strong nuclear force. They do not feel strong nuclear force, or they do not interact with strong nuclear force, because leptons are not present in the nucleus. And this question has 2 marks, so these are answer marks. If you have written 22, you will get 1 mark, and the second mark you will get if you have written 10, means the proton number. For this question, it is given to us the quark composition of a nucleon in the sodium-22 nucleus is changed during the decay. We need to describe the change to the quark composition of the nucleon. So first of all, let's try to understand what is nucleon. Nucleon simply means that any particle in the nucleus. So simply we can say nucleon means any particle in the nucleus is named as nucleon. Any particle in the nucleus is called nucleon. So simply we can say any particle in the nucleus. In the nucleus we have protons and we have neutrons. So protons and neutrons, we call them nucleons. Let's try to understand a little bit more about beta plus decay to answer this question. First we will start from sodium. Sodium-22 means the mass number of sodium is 22 and atomic number of sodium is 11. This decays to a daughter nucleus by beta plus decay, or simply we can say by emitting beta plus particle and electron neutrino. This daughter nucleus, it has atomic number 10 and its mass number is 22. Now we need to understand mass number. First of all, we will look at this mass number. So here is also the mass number. If you look at this mass number, sodium has 22, the mass number of sodium is 22, and the mass number is the sum of proton and sum of neutron. And daughter nucleus, this also has the same mass number 22, and this is also sum of protons and neutrons. Sum of protons and neutrons. Atomic number is 11. It means we have 11 protons here. Neutron number is 22. So 22 minus 11, it means we have 11 neutrons as well. 22 minus 11 is neutron number. But if you look at this daughter nucleus has atomic number 10. It means it has only 10 protons. So neutron number in this case is 12. So if we look at neutron number, we can see neutron number is increasing. So if the neutron number is increasing, and if you look at the proton number, this one is decreasing. So we have minus 1 here. Proton number is decreasing, the neutron number is increasing. So it simply means that in this case, one proton changes into neutron. So we can simply write down, in this case, one proton decays into neutron. So this is one thing you can write down. Proton decays to neutron. And the quark composition of proton, it has 2 up quarks and 1 down quark. And neutron has 1 up quark and it has 2 down quark. Describe the change to the quark composition. So simply we can say in this case one up quark decays to down quark. So simply we can write down in this case up quark changes to down quark. We can say up quark changes to down quark, and that is the change in quark composition. Up quark changes to down quark, and this question has only 1 mark, so this is the 1 mark. Kind of typical question you need to understand. I have explained this one in detail, but if you are very clear about this one, so beta plus simply means that proton decays to neutron. If it is beta minus, then neutron decays into proton. For part B, it is given to us a baryon consists of quarks that are the same flavor, same type. Means all of them, they are same type of quark. Means all of them, they can be down quarks, they can be anti-down quark, they can be up quarks, they can be anti-up quark, and so on. It is also given to us the charge of the baryon, that is negative to E. Means this is the charge on single electron. For part 1, we need to calculate in terms of E the charge of each quark. The first thing we need to understand is that we need to understand what is baryon. So very important one. If you don't understand what is baryon, maybe it will be quite difficult to answer this problem. First of all, let's try to understand what are baryons. Fermions, I will start from fermions, or simply you can say matter and antimatter. So fermions consist of matter and antimatter. Fermions can be classified into 2 classes. We classify them into hadrons and leptons. They can be classified into hadron and leptons. Hadrons can be classified into baryons and mesons. Baryons and mesons. Baryons consist of 3 quarks. They can be quark or they can be anti-quarks. Consist of 3 quarks. Mesons, they consist of quark and anti-quark. Means one of them will be quark and other one will be anti-quark. So mesons, they consist of 2 quarks. One quark, one is anti-quark. So mesons consist of 2 quark and anti-quark. So we can simply write down they consist of quark and anti-quark. But baryons, they consist of 3 quarks. Hadrons, they feel the strong nuclear force. So we can say feel strong nuclear force. I'm using SN for strong nuclear force. Leptons do not feel strong nuclear force. Do not feel SN means strong nuclear force. Hadrons are heavier particles. So we can say they are heavy particles. Leptons, they are lighter particles. So we can simply say lighter particles. Examples of leptons are electrons and neutrinos. So simply we can write down here electrons and neutrinos. So these are examples of leptons. If you look at examples of baryons, baryons consist of 3 quarks. So the examples of baryons are protons and neutrons. So simply we can say neutrons. Let's try to answer part 1. For part 1, we need to calculate in terms of E the charge of each quark. But now we understand each baryon, it consists of 3 quarks. So simply we can say in this case Q is the charge on single quark. So the total charge 3Q, this has to be equal to negative 2E. From here we can find out Q, this one will be equal to negative 2 by 3E. So this is the charge on single quark of baryon, because it is given to us baryon consists of quarks that are the same type. Means all of them, they have the same charge. So this is the charge on each quark of baryon. If the total charge on baryon is equal to negative 2E. So this is our answer for this question. And this question has 1 mark and this is answer mark. If you have got this right answer, you will get this mark. For the second part, we need to state a possible flavor or possible type of the quarks. But we have already determined the charge on each quark. So this is the charge on each quark. Now we need to find out type of quark. For this one, we need to understand different types of quarks. So we will start from a quark. So we have first one is a quark. We use small letter U, the symbol for a quark. And in the first generation, we also have down quark. And symbol for down quark is small t. The second generation means after up and down quark, we discover charm quark. This is charm quark. Charm quark and strange quark, they belong to second generation, so strange quark. After charm and strange quark, we discover top quark. Symbol for this one is small t. Top and bottom, they belong to third generation. Mean first we discover up and down quark, they belong to first generation. Then we discover charm and strange quark, they belong to second generation. Top and bottom were discovered at the end, so they belong to third generation. Top and bottom. Symbol for bottom quark is B. Now if you look at the charge of these quarks, charge on these quarks, so this is first, second generation, and this one is third generation. Now we need to look at the charge on these quarks. If you look at charge on up quark, charm quark, and top quark, you can see something higher, up, charming, top, something better or something higher. So all of them, they have charge plus 2 by 3 e. So this is the charge on all these quarks. They have the same charge. Now if you look at this bottom row, all the quarks in this bottom row, they also have the same charge, and the charge is equal to negative 1 over 3 e. Means the charge on down quark, charge on strange quark, and charge on bottom quark is equal to negative 1 over 3 e. There is a way to remember the charge on these quarks. If you look at this top row, all the quarks in this top row, they sound, the name sounds something higher, like up, like charming, top. They sound something higher. So that's the reason the magnitude of charge on these quarks is higher and positive. Higher and positive. So I will say higher and positive. If you look at this bottom row, down, something down, strange, doesn't sound good. Bottom also lower. So all these quarks, they have lower magnitude of charge, and charge is negative. So this is one way you can remember. Now let's try to answer this question. We need to state possible type of quarks. If you look at top quark, has charge plus 2 by 3 e. Anti-up quark, charge negative 2 by 3 e. Now if we talk about anti-charm quark, charge on anti-charm quark will be negative 2 by 3 e. And the charge on anti-top quark, that also will be equal to negative 2 by 3 e. Now for this question, you can say anti-up quark, anti-up, we can say, you can also say anti-charm quark, you can also say anti, I will be writing here, you can say anti-top quark. So you can mention any one of them, you will get 1 mark, and that mark is B mark. So you will get B mark for this one.